So hi guys, we are group 228. So our topic is understanding ride demand pricing and where it impacts in Boston rideshare data. So Boston is a unique city because it has one of the highest student population in the US. During exam week, daily routines change. Students travel at unusual hours, prioritize time efficiency, and rely more on Uber and Lyft. In this project, we analyze Boston rideshare data to understand how time patterns, search pricing, and weather jointly shape ride demand and revenue with a specific focus on exam week behavior in a college city during 2018. Next slide, please. So for our analysis, we use Boston rideshare trip data, including time, price, search multiplier, and pickup location, and so on. We match this with hourly weather data. Our method is data analyzed using interactive Tableau dashboards. We focus on three dimensions that are especially relevant during exam week. First, time-based usage pattern. Second, pricing and search behavior. And third, how weather affects demand when students have less flexibility. So as we can see in this graph here, we can clearly see the pickup value as the map of Boston. We can see the downtown Northeastern University and Boston University has the highest pickup volume in Boston during this week. Next page, please.
So when do people write? We begin with the most basic question. And during exam week, students still have fixed commitments like exam and study sessions. So time patterns are critical. And understanding these patterns help us whether rideshare usage remains structured or becomes more random under academic pressure. Next slide, please. Uh, so our answer is we have a morning and evening peak script. And this chart shows that ride demands follow strong daily cycles with clear peaks during weekend commuting hours. Even during exam week, usage remains predictable rather than chaotic. Chaotic, chaotic, sorry. This suggests that students that commuters still follow structured schedules, exam classes, libraries leading to consistent demand peaks instead of random spikes. And next slide, please. And so if demand is predictable, how does pricing respond? Since demand during exam week is predictable, the next question is how this price responds to the demand. And Uber and Lyft use usage pricing to balance supply and demand. So we want to see whether pricing moves smoothly with demand or behave more accurate during high stress periods like exams. And next slide, please. So the pricing analysis shows there are three key points. First, surge does increase during high demand hours, which is expected. And second, surge has more than demand, meaning pricing reacts to short-term supply conditions rather than just overall volume. And third, price increases are non-linear. Small changes in demand can sometimes trigger noticeable fare changes. During exam week, this indicates that price is sensitive, and even when demand itself is relatively stable. And next slide, please.
So what about external shocks? Beyond the time pricing, we consider external shocks, especially weather. During exam week, students have little flexibility. Exams happen regardless of rain or snow. So weather becomes an important factor in whether students choose Uber or Lyft instead of walking or taking public transit. And how does weather affect demand? The analysis shows that adverse weather increase ride demand. Rainy conditions lead to higher hourly usage, and demand spike adjacent closely with weather shocks. During exam week, weather doesn't just inconvenience riders. The fact that the forces demand into rideshare platform because students still need to reach exam on time. And where is revenue concentrated? Finally, we look at whether revenue is generated. Even if demand rises across the city, revenue may not be evenly distributed. In college city like Boston, exam week travel tends to cluster around campus, library, and central neighborhoods, like Boston University and Northeastern University. Revenue concentrated by location. The result shows that revenue is sparsely concentrated with downtown and key district dominant total revenue. The mean high demand does not translate evenly across the city. Instead, student dense and centrally located areas generate a disproportionate share of Uber and Lyft revenue during exam week.
So we also analyze how weather affect price. So the first two weather condition we analyze is precipitation intensity and temperature. So we can see the distribution here is quite even, which saying that price precip intensity and temperature does not really have a high correlation with price. But we can see as precip intensity increase and as temperature increase, the surge multiplier will increase. But probably because our data set is too large, so it averaged down the outliers, and which eventually creates a nearly horizontal linear regression line. Next slide, please. So the pattern is similar for humanity and visibility. And in this case, also similar with what I said in the previous slide situation. So this too, weather did not also affect price very much. So we can see it's quite random. And the linear regression line here is also near horizontal line. Next, please. And also it's same with the wind speed, but a little bit different here in wind speed is that the outlier in search multiplier is probably 20% more than the previous situation. So we can see that the dark blue dots here is much more than previous graph, which is saying that the wind speed has much impact in search multiplier instead of price. Next slide, please. So we also figure out how the snow affects on price. But in our data set, we don't have a variable called snow. So we just manually input snow as when temperature down and when precip intensity is high. So we can see that here is a snowing zone. And during the snowing zone, the average price is much higher than the other blocks, which saying in the snow time, the average price is higher than other situation. Next slide, please. So this Gantt chart here reveals substantial heterogeneity in how rideshare market responds to weather shocks, with some rain events causing brief disruption and other producing prolonged periods of elevated price, indicating that market recovery dynamics are even specific rather than uniform. So next is the key insights. So to summarize our finding, ride demand follow predictable time pattern. Even during exam weeks, search pricing react dynamic but unevenly. Whether acts as demand amplifier, especially when flexibility is low. Revenue is concentrated in central location, not spread evenly. These insights are especially important for managing rideshare operations in the college city. Next slide, please. So in conclusion, our analysis shows Uber and Lyft usage during exam week in Boston is shaped by structured time patterns, responding price and weather-driven demand shocks. Effective rideshare operation in a college city therefore require time-aware pricing, weather-sensitive demand management, and location-focused strategy. Understanding exam week behavior allow platform to better anticipate demand and allocate resources more efficiently. Thank you very much.